It's helpful. I don't think I'm going to do necessarily every question. But like the first one, I mean, you would just simply square both sides. That would cancel out your radical. So you just have what's underneath. 7 squared is 49. And then just solve this two-stepper. So subtract the 1, divide by 6. Just get that x is, what would that be? 8. Similar idea for question 2. Remember, before you square both sides, you got to make sure your radical is isolated. So you want to first, it's almost like if you have the equation 2x plus 10 equals 4, you want to get the x by itself. So you got to subtract the 10. So you have 2 square root of x plus 2 equals negative 6. You want to get rid of this 2, so that's multiplication, so you divide. So then you have the square root of x plus 2 equals negative 3. And now you have a question that's basically what we just did in number 1. Square both sides. Just be careful when you square it. Remember, negative 3 squared, negative 3 times negative 3 is going to be positive 9. Remember, anytime you square, you're always going to get a positive result. So that's an easy kind of mistake to make. If you subtract 2, you should just get x equals 7 though. So that's definitely something to be on the lookout for in questions like these. Is just be careful if you're ever squaring like a negative number, you should always get a positive. Just be careful with signs. That's an easy thing to make mistakes with. Whether you're doing radical equations or anything else, like that's something I'm very guilty of. I make mistakes all the time with my signs. So just kind of check your work. Just make sure you're avoiding that. Question 3 is a good one to look at. I think this question's they can be deceivingly hard, and I'm going to write one tip for a question like number 3. I mean, the first thing you want to do is get like what you have up to your fraction exponent by itself. Question, Corey? Oh, yes. So one thing we should be doing, I almost forgot. I'm glad you said that. For all of these questions, you always want to make sure you plug these in to make sure they're not extraneous. So let me just check for the first 2 we did. I mean, 8 times 6 would be 48 plus 1. That would be the square root of 49 equals 7. This one would work if you check it. Let's check the second one. 7 plus 2, that would be the square root of 9. That would be 3 times 2 is 6. Plus 10 does not equal 4. So good catch. Actually, this one would be extraneous if you check your solution. So I'm glad you said this. So this one would technically be like no solution then, since you don't have any answers left. But so if you probably should write no solution, but if you just crossed out your answer and you just didn't have an answer, I mean, I wouldn't mark you wrong, but usually it's a good call to like just be really clear. So, but yes, so yes, that is my apologies. Yes, but for all of these questions, and this is what the first page of your quiz is going to look like, you want to make sure you're checking your solutions. So thank you for pointing that out. And I'll have these same directions. Like I just didn't read them myself. I'll remind you. But yes, be careful about that, because for sure there will at least be some questions on your quiz where there are some extraneous solutions at least. All right, so but sorry, back to question 3. You want to get what you have up to your fraction power by itself. So like the first thing we need to do is just divide that 3. So we'd really have this x plus 1 up to the 2/3 equal to 4. It's probably because we didn't do a ton of these because there wasn't any in Delta Math, but we did see these in the notes. Remember, to get rid of a fractional exponent, you do the reciprocal. Like you take both sides up to the reciprocal power. So this would just, on the left side, we would just get x plus 1. One thing you got to be really careful about, if you have an even denominator, remember the denominator is your radical, or like your root. If you take an even root, you have to have a plus or minus. So say this bottom was a 3, I wouldn't have to put a plus or minus. But if it's an even, you got to put a plus or minus. And you could either put this in your calculator, like 4 up to the 3/2, or you could work this out mentally. Like you can do the root or the power first. But if you took the square root of 4, that would be 2. Up to the 3rd power would be 8. Or you could also take 4 up to the 3rd power, whatever that would be. What would that be? 64. Then square root it, you would get 8. Like the order doesn't matter between the the power and the radical. But usually it's easier if you can do the radical first, because then you get a smaller number to deal with. But then if we solve this, you would subtract 1 from positive 8 and negative 8. So you would get, if you did the positive, you would get 7. So like positive 8 minus 1. And then if you do the negative, negative 8 minus 1 would be negative 9. We want to just plug these in really quick. I'm going to pause the video just so if anyone is watching this later, hopefully it's not. All right, so I did pause the recording if you are watching this video later, but we plugged in both of these into this original equation and they both checked out. They both equal 12. So like one tip though, if you're dealing with, oops, I didn't mean to delete. If you're dealing with a fractional exponent, if you have, like when you do your, like if you take both sides up to a fractional exponent, if your bottom is even, put a plus or minus, like when you do your root. If you forget, I mean, if you just always put a plus or minus, you would just see that you're going to get an extraneous solution if you have like a cube root, like, or something like that. So if you check your solutions in the end, it wouldn't matter as long as you put a plus or minus, but don't forget to put a plus or minus if you have an even denominator, like when you take a power, because it's like you're taking a square root. If you take the square root of both sides of an equation, you get a plus or a minus. So just be careful, because there will be a question with, there'll be one question, I believe, with like a fractional exponent. So I don't know if the denominator is even or odd, but if it is even, you need to put that plus or minus. You could get really lucky and maybe the answer that from that plus or minus turns out to be extraneous. So I guess you could like really clutch it out in a sense, but I mean, you're just like, I mean, that just comes down to pure luck. Question 4 is a very easy one. You didn't actually see any of these in Delta Math, but remember, if you square both sides, basically your radicals just go away. So you just write what you have underneath. And then just solve this pretty basic equation. Get your x's to the same side, get your constants to the other. So I would just subtract 2x to the left side, subtract the 1 to the other side. So if you did that, you would get 1x equals 6. So I mean, that's really your answer. But we do want to check this. So, I mean, if you plug that in, 6 times 3 plus 1, that would be the square root of 19. If you plug it in on the other side, you would still get the square root of 19. So, I mean, everything checks out. So question 5 and 6, these ones are a little bit trickier. Like I said, you want to get the radical part by itself. So, I mean, this one you would just subtract. So you'd have x minus 3. Obviously, we can't combine those. So now we're ready to, once you get the radical part by itself, you can square both sides. Just be careful when you square this right-hand side, you're squaring the whole thing. And it's not just going to be like x squared minus 9. You actually got to FOIL that out. Like that's a really common mistake. Because x minus 3 times x minus 3, if you need to do it like on the side, but that's this, or if you can kind of FOIL it in your head, feel free. But that would be x squared minus 3x minus 3x. So that would be minus 6x and then plus 9. Because if you FOIL this, this is what you would have had. I just kind of combined it in my head. So I'm just going to erase that though. So now we're ready to solve. My advice for this question though is if you won't, like, it's usually easier to factor if you keep your x squared as positive, because then you don't have to worry about a coefficient or anything like that. So I would just subtract everything to the right side, or like add it, like, but basically move everything to the right hand side with that x squared, because it's nice to keep that x squared as a positive x squared. So we would just have 0 on the left side, x squared minus 11x plus 10. This factors nicely. I mean, worst case, you would have to do like quadratic formula or something like that, but I will try and make it work nicely on your test just because I feel like you got enough to worry about. But this would be x minus 10, x minus 1, because what multiplies to 10 adds up to negative 11. So you would get x equals 10, and you would get x equals 1. We should check these solutions though. If you plug in 10, that would be the square root of 49. That would be 7 plus 3 is 10. So that does equal 10. So that one checks out. If you plug in 1, that would be 5 minus 1 underneath your radical. That would be the square root of 4, which is 2. 2 plus 3 does not equal 1. So I believe this is extraneous if I did that right in my head. Question 6 is honestly the worst of the group because you can't, like, there's no way just to get like a radical on its own without having like a radical and a constant on the other side. So you need to basically, I would just start by squaring both sides. There's really nothing you can gain from moving stuff to different sides. I mean, if you'd rather square the square root of x plus 2 versus the other side, let me see, would that be better? Is it going to be bad to FOIL this? Maybe. Yeah, I actually think, I don't know, I'm not 100% sure, but I'm thinking it would probably be better to write it like this. Because I'd rather square this versus this. I think this would be harder to square. Like I'm worried about that x minus 8. So I know this won't give me too many problems. So I think this is probably the way to go. So if we square the square root of x minus 2, like we FOIL that, you can do it in your head also, but square root of x times the square root of x would just be x. Then you would have minus 2 square root of x minus 2 square root of x. So that would be minus 4 square root of x. And then negative 2 times negative 2 would be 4. On the right-hand side, when we square, we're just going to get that x minus 8. I'm just going to erase what I have there. So if we move everything, well, basically the x's are just going to cancel out, actually. And I could subtract the 4 over, I guess, to start getting this radical by itself. So I would have negative 4 square root of x, sorry, equals negative 12. You can divide the negative 4. So positive 3, then square both sides. You get x equals 9. And if you do plug this in, when it, just trust me, it does work. But you could verify that if you'd like. But this is one of like the harder ones from the Delta Math. You did have, I think I made 3 of these or 2 of these, but yeah, I think you might have gotten away if you just squared at the start. But I think honestly, you want to get that square root of x minus 8 by itself because that one's it'll probably make your life easier. I haven't worked it out the other way, but I'm worried that you might run into some issues. So this is like the first big part. Like there's going to be quite a few points that come from this section. So I definitely would make sure you're pretty good with these or feeling all right. There will be very similar types of questions though. Like you will for sure see one like number 4 where you just square root both sides and you just write what's underneath. You will like you'll see very similar types of questions if that makes sense. Obviously different problems, but like I try to make it line up pretty good when you take your quiz. But I would definitely make sure you're feeling all right with this section because a lot of your points, this is a good chunk of where your grade will come from. The next kind of question on your quiz, this is like the graphing question. So for those that aren't able to print it out, try your best to graph it if you can, like draw like a coordinate grid. It doesn't have to be 100% accurate, but try and like label like put your dashes so you can kind of label the points if possible. But for this one, they want you to find the inverse of this function, and they want us to graph the original and the inverse. So, I mean, if you want to just start by finding the inverse, so you remember you just you write it as, you want to change that f of x to a y, swap your x and y, and then you want to solve for y. So, I mean, you would add the 2. So I write a little bit too big. This is not going to be pretty. So you would have to square root both sides to get rid of that power of 2. But remember, when you square root both sides of an equation, you got to put a plus or minus. And then you would subtract the 3 over. So sorry, I don't know if this is how sloppy this is, but you would have plus or minus the square root of x plus 2 minus 3. Okay, and they want us to graph both of these. So, I mean, if you remember how to graph a quadratic, like this is in vertex form. So your vertex would be -3, -2. Remember, like opposite of the inside, the outside stays the same. So -3, -2 would be here. So I'm gonna write my, sorry, I'm writing really sloppy. I think I have this written in paper. So I'll post like my neater copy as well. So I'm gonna write my original points, but -3, -2. And then ideally, we want to get a couple more points like on both sides of our vertex. So I probably want to plug in like -2 and then maybe plug in -1. I mean, you could pick other points if it looks easier to plug in, but I'm just going to plug those into the original equation. So like parentheses -2 + 3 squared -2. If I plug in -2, I'm going to get -1. And if I plug in -1, I should get the same thing because it's symmetric, but you could verify -1 + 3 squared -2. You also, wait a minute, what did I do wrong? Oh, what am I doing? You want to pick equal distance points. So -2, if I did -2, that's one bigger. I'd want to do -4. So sorry, like you want to pick one on both sides of your point. Like if -3 is here, I want to plug in -4 and -2. I mean, I guess it doesn't matter, but it's nice to kind of pick equal distance points because we're going to see it's symmetric. Like if you plug in -4, you'll also get -1. So sorry, I kind of goofed there. But if you plot these points, you'll see that your parabola looks something like this. And you might be wondering, well, I mean, we kind of barely looked at it in section 6.8. You might be asking yourself, how the heck do I graph something that looks like this? Well, you don't need to know how to graph something like this. Remember, to graph an inverse, we can just swap our points. So my inverse points, if I just swap these around, I would have -1, -2, -2, -3. I'd have -1, -4. So I just want to plot these new points. So -1, -2 would be here. -2, -3 would be down here. -1, -4 would be here. And remember, it's going to make the same shape. So it's still going to be like a parabola, but it's sideways. So you don't need to know, I mean, if you don't know how to graph either the function or, you just need to know how to graph either the function or the inverse. As long as you can graph one of them, just swap your points to get the other one, if that makes sense. And you're also like, if you're really having a bad time, you could also like either plug this into your graphing calculator, use your table to get some points, or you could use Desmos as well. But honestly, this is something you should hopefully be able to graph without like a tool. I would hope at least get some points. But so they want the domain and range of our function in the inverse. Remember, the function's the one in green. So my domain is going to be all real numbers for that green function. Like it's going to go to the left and to the right forever. But the range, if you look, like this function, it's everything above -2. So you could write that as y greater than or equal to -2. Or if you prefer interval notation, you could do -2 to infinity. Whatever you prefer. For our red function, our domain is not all real numbers. You're going to see that it's everything. Remember, your domain's like everything left or right. It's everything bigger than -2. So it's x since it's domain. Or you could also write it as an interval -2 to infinity. But our range is going to go up and down forever. So it'd be all real numbers. So that's sloppy. One thing to notice for your domain and range, you should see that they're just swapped. Like if you look at your original function and your new function, the domain and range basically just flip-flop. Like the range is really the domain of the original function, and the domain is really the range of the original function. So like you should see that like that you should kind of see that these are basically going to be the same, and these are going to be the same. Obviously, with your domain and range though, like you're going to have an x instead of a y though. Like, is your new function, like is the inverse of function? Well, I mean, you can either look, it fails the vertical line test, or remember, if your original function fails a horizontal line test, it's not going to be a function. But this would not be a function just looking at your graph, it fails the vertical line test, or your original failed the horizontal line test. But since you have a picture of both, I mean, you could just look at your inverse. So I know we didn't do like necessarily problems like this, so I hope this one's not too bad, like graphically. I mean, we did like, we looked at all these concepts, but not like together like this. So I could like, hopefully this isn't too bad. But basically, just find your inverse function, plot your original function, and just swap your x and y points to get your new function. You don't have to know how to, like, you don't need to know how to graph this. I mean, if you want to make a table of values, you could, but like I said, if you already have your points, just swap your x and y's from your original function to get your new function. Okay, then kind of like the last kind of big thing, like this is kind of one of the other big things, is just finding the inverse if they give you a function. For sake of time, I don't know if I'm going to do all of these, but this is basically what we just kind of did in number 7. You're going to swap your x and y, and you're going to solve for y. And some of these are going to be easier than others. But if you subtract the 4, and divide by 2, sorry, I write way too big, but I would you basically get y equals x minus 4 over 2. I know Delta Math was picky. They would want you to write that as like 1/2 x minus 2. I don't care if you leave it like this or simplify it, but remember, you should write your final answer with this inverse notation. So like this would be your final answer. I'm going to skip number 9. There's one thing you got to be careful when you're doing these. Anytime you take an even like root or even radical of both sides, you got to put a plus or minus. So if you're square root in both sides, you got to put a plus or minus. Or if you were taking the 4th root of both sides, you got to put a plus or minus. If you're taking an odd root, you don't have to put the plus or minus. So like for question 9, like here, I'm going to skip I don't know if I can like skip this step just for space, but after you swap your x and y, you're going to have this. So when you square root both sides, don't forget to put this plus or minus. And then obviously you would just subtract the 1 over. So I'm going to kind of like abbreviate my steps. I hope this isn't confusing, but you would get that the inverse is this plus or minus square root of x minus 1 once you finish solving for your y. But like this question here, when you take the cube root of both sides, you don't have to put a plus or minus. So only like with an even root. So for example, number 11, like when you take the 4th root of both sides, you got to put a plus or minus. This would be plus or minus the 4th root of x equals y, or your inverse would be. So only when you're doing like an even radical do you put a plus or minus. If it's like a cube root, or I mean, you probably won't see it, but if you ever had like a 5th root or a 7th root, you don't put a plus or minus. But if you have an even root, like the square root, the 4th root, the 6th root, the 8th root, I mean, you probably won't really see 6 roots or 8 roots. I think when they would really ever come up in like a real application. Maybe it exists. All right, so I will make, and like I said, I know this is a little bit sloppy because I write like a child on my iPad more than I already do. So like I said, I will upload like a paper copy worked out. So hopefully it's a little bit more legible. And I'll work out all these questions. I know I skipped kind of number 10, but just for sake of time, I want to look at these next couple sections. So 12 and 13, they just want you to prove if these are inverses. So basically, remember for this, you just want to see is f, what am I writing? Is f of g of x going to equal x, like when you simplify? and is g of f of x also going to equal x? If they both equal x, it's an inverse. If one of them doesn't equal x, you can stop. They're not inverses. So like for this one, I mean, if you plug the g function into the f function, you would have 2 parentheses 1/2 x plus 4 minus 8. If we start simplifying this, like distribute, you would get just x plus 8 minus 8, which does equal x. So far looking good. G of f of x, that's like you're plugging in the f function in for the x and the g function now. So that would be 1/2 2x minus 8 plus 4. If you distribute, you would get x minus 4 plus 4. So it does equal x. So these are inverses. If they even if they equal the same thing, let's say you got that they both equaled, I don't know, like 3 minus x or something weird, like they wouldn't be inverses. They both have to equal x when you plug them in. If you don't like these composite functions, another way you could prove it, I mean, I would like you to do it like this, but if you really are struggling with this, sorry, this announcement. Sorry about that. But you could also just find the inverse, like swap your x and y and just show that it's going to give you that other answer as your inverse. That would also be proof. I'm going to skip 13 for now, or I mean, maybe it's worth doing. I'm pretty sure 13 doesn't work if I remember. I don't have my key in front of me. But if you plug this into here, like if you did like the first one, like 5 parentheses, this whole thing up to the second power minus 2, basically you would just get rid of your root. So then when you multiply this, like really you'd have 5 times x plus 2 over 5. This would cancel. So this would actually equal x for this first one. But if you plug this, the other one in for the x, let's see if it works. I'm kind of skeptical. Because that would be, yeah, I'm guessing it's not, because if you plugged in like 5x squared minus 2 for that, you would have this, that plus 2 all over 5. So like the 2's would cancel. Oh, actually, I think this works, because you basically have the square root of 5x squared over 5, which cancels, and then the square root of x squared would just be x. So I'll double check my key, but that one actually, that surprised me. Like just at a glance, I was like, didn't look like that was going to work. Okay, 14 and 15, I was debating whether I should really put these or not. I definitely, if I put these questions on your quiz, they're going to be extra credit. But one thing I didn't really do a good job, so I'm going to try. I mean, this is it for the review, just FYI. So I'm going to try and see if I can do this justice in the last. I only have 7 minutes, unfortunately, since the iPad wasn't cooperating. That kind of screwed me a little bit, but basically they want you to find the inverse and then state the domain and range. So there's nothing really like too crazy about finding your inverse, at least this first one. I don't know. We'll look at the second one in a second if we have time. But I mean, if you just find your inverse, here's where it gets a little bit tricky. Not right now. I mean, but if you just swap your x and y, solve for your x, you would square both sides. You get x squared equals y plus 3. Subtract the 3 over. So basically, I know I'm going a little bit fast, but if you got your inverse, you just have that the inverse equals x squared minus 3. But here's where you like where these problems, if you're talking about domain and range, things can get a little bit interesting. So I'm just going to call it f of x. Like our original function was f of x. We have to think about what the domain and what the range of that function would be. So with your domain, is there any, this is something I probably need to maybe do a better job of explaining, but is there anything you can't plug into a square root equation? Well, you can't have any negatives. So for example, if I plugged in -5 into that original function, that's bad because I'd get the square root of -2. That would be undefined. So basically I want to think about what can I plug into that original function? What can't I plug into that original function? So for example, I could plug in -3 into that original function because that would give me the square root of 0, which is just 0. That's a-okay. But I can't plug in anything smaller than -3. Like if I plugged in -4 into that original function, that's a problem. If I plug in -5 into that original function, that's a problem. If I plugged in -3.1, that would be a problem because I'd get -0.1 underneath my radical, which is not okay. So my domain would basically be every x that's greater than or equal to -3. Basically, I can plug in anything. I can plug in -3 and I can plug in anything bigger. Because if I plug in -2, that's a-okay. My range, basically, think about, is there anything that function couldn't equal? Well, this one's actually trickier than I was thinking. If you take a square root of a number, you can only get positives. So this is probably too much. I might put this for like extra credit on your quiz, but I'm not. I'm shoving too much, I think, at once. But basically, your range would just be greater than or equal to 0. Because if you take a square root of a number, like you can't get a negative. Like that's never going to happen. Like the square root of 4 is 2. The square root of 1 is 1. The square root of 0 is 0. So you can get 0, but you can't get any negatives. So once you figure out your restrictions, your domain and range basically just swap for the inverse. So like my domain would be basically the same thing as my range, except I'm going to put an x. So it would be x greater than or equal to 0. And my range would basically be the domain of the original. Or sorry, would be the, yeah, it would basically be the domain. Basically these, like when you go from here to here, you just swap these. I don't know if that makes sense. I'm throwing a lot at you, so I might just put these questions on your quiz to see if anyone can figure them out, like if it makes any sense, but it will 100% be for extra credit. I don't know, maybe I shouldn't do it, but I'll just, that's the idea. I guess one thing you should check, just make sure there's no other like restrictions, but you can plug everything into x squared minus 3. Like there's no problems there. Really what you want to be on the lookout for is if you have a radical or a fraction, because you can't have 0 on the bottom of a fraction and you can't have negatives underneath the radical. So we do have 3 minutes. I'll try and do this last one really quick. If you solve for your inverse really quick. So what am I doing? 2x. And if you swap, basically you'd want to multiply the 2y over. So you get like 2xy. So you want to get the y by itself. So you'd basically divide the 2x back over. So this one's a little bit weird. You basically get the inverse is what you started with. Wait a minute, did I do that right? I think this is kind of like a special case. You can this, what is this called? There's like a name for this. It might just be like an identity. But is it like there are functions where like the inverse is the same as the original? Let me just make sure I didn't goof up. But yeah, basically you would get the inverse is what you started with. Like, I'll double check my math, but I'm pretty sure as long as I didn't like make a major goof, but I don't see anything I did. So you want to think like for my original function, like what would my domain be? And this is something we will see this later, like I believe in chapter 8, we'll talk kind of more about this, but this might be a good preview. But my domain, what can't I plug into that original function? So 1 over 2x. The only thing with fractions that you can't have is 0 on the bottom. So basically, I could plug in everything into that original function except 0. So you plug 0 in that bottom, you're going to get 0. So basically, it would be all real numbers except x can't equal 0. Your range, is there anything that fraction can't equal? No, I mean, fractions can equal 0, they can equal negatives, they can equal positives. So, I mean, the range would just be all real numbers. There's no issues there. So, like my inverse, this is a little bit, basically, they would just swap. But I'm gonna lose people. I didn't do a good job. But technically, since your inverse is also a fraction, you still couldn't have x equals 0 for the domain. So I know I didn't do a great job, but one thing you got to be careful about when you're finding inverses, if there's something you can't do in your original function, that's going to reflect in your inverse. That's kind of what I'm trying to show, but I know I didn't do it 100% justice. So like I said, questions 14 to 15, you won't see anything like that on your quiz. I might put one as just like extra credit just to see if anyone can kind of understand what I'm saying here at all. But